Layout. And the idea today will be to show you how you can make digital extras in a simple way, because in that post-pandemic era, it will be really difficult to have multiple extras on sets. So we wanted to show you how you can maybe change that practice and now put 3D characters into a really simple way by using the Golem technology here. So what I've been showing into the video right now was one couple of customer samples, from Game of Thrones to small commercials. We always targeted into being able to help everybody, even small studios or really big studios. And I'll try to demonstrate that making crowds today is super easy, and you'll be able to figure that in a simple way on your side. Before getting just started, we are a Maya plugin, so everything I'm going to do here will take place into Maya. At the end, I even show you how you can bring your simulation within Unreal if there are some people who want to, render their simulation within Unreal. But before getting started, I just want to maybe show you a workflow. It's going to take a couple of seconds here just to make sure that we are on the same line and that we're going to speak about the same stuff here. So that's the crowd simulation and layout workflow, that whatever the package you pick, it can be Golem or anything else, you have something similar here. So it's kind of divided in two parts. One is the pre-production part. So you can see here at the top, this is where you need to convert the assets. So whenever you need to make digital extras or crowd, you always need to bring both characters within the Golem system and motions as well. I'm going to skip that part here. We've got plenty of tutorials which shows you how you can bring your characters within Maya. Into the video I showed you, you can see some characters, some studios were using zombie characters, horses. So this is assets they made at the studio and they converted them to make them Golem compatible. Here I'm going to play, during that demo here, I'm going to play with some assets that we provide. So when you download the software, you can grab some assets that comes with the software. So you can get started right away without having to provide those assets. But keep in mind that anytime if you need to provide your own motions, your own characters, that's something can be done pretty easily. Just a quick word about the motions. Something which makes us different from the others is that we're having two stuff within Golem which are pretty specific. One is motion blending. So it means that, let's say you got a walk animation and a run animation, we can make the transitions for you automatically. You don't have to provide those, and we make sure that you don't have sliding feet and all those weird artifacts. The second thing, which is even more interesting, is called retargeting. So it means you can grab any animation from any source and you can replay that onto any other character, even if they don't have the same number of bones, the same number of chains or whatever. We always allow you to replay motions from one source to another character from another source, which is really interesting when you do, especially VFX. You can grab mocap animations from different places and make sure that you can replay them all onto your characters. So that's the pre-production part. So when you're done with converting your characters and your motions, you end up with a Golem character file and the Golem motion files. And anytime you need to make a shot with 2 to thousands or millions of characters, you need to go through those steps here. So first, you need to bring your characters in. So let's say you make a CT simulation scene and you want to have characters into the background. You're going to bring the man character, maybe the woman character, maybe the car character, maybe some dogs, some birds. So those are going to be different Golem characters. You bring them in within your scene. You place them. So you define how many you'll have, what are going to be their initial positions, orientations, how they're going to be spread into the environment. Then this is step 4. This is one step, but this is where we're going to spend most of our time today. It's assigning the brain to your types of characters. So you want the man and the woman to navigate. So you need to specify some behaviors to say what they're going to do, how they're going to do it, how they interact, and so on and so forth. And as this is taking place within Maya, we will not have full geometry within the Maya viewport. We will not able to get thousands of Maya characters within the Maya viewport. So what you have here is going to be some proxies. I'm going to show you that later. But you'll be able to see some stuff, but that's not exactly what you get at rendering time. So to see what you get at rendering time, you need to first export the simulation. So we don't we don't export geometry here. Let's say you do thousands of characters and you export as FBX or LMBEC, it will be really, huge gigabyte sized file, which not be able to render and handle easily. So what we do export is a specific Golem cache in which we just store the posters of the skeletons. And then after that, we got some plugins. So we got one for Arnold, for 3D Light, for V-Ray, Redshift. I'm forgetting one. So V-Ray, Arnold, yeah, Randoman, 3D Light, Redshift. And those plugins allow you to take the cache, take the T-pose character, and rebuild the geometry on the fly when you need it. And I skipped one step, and I'm going to end with this, is that here we got something called simulation layout, and this is also what makes us different from the others. We got that full software, which is called Golem Layout, which allows you, once you have exported your simulation, to edit the simulation results and to be able to, reach the 100% what is required from the shot. You do your simulations and it's never perfect. You show that to the director or the art director and he tells you, I want to remove some of the characters. I want to change some of the assets. I want to reanimate some of the characters. So with other solutions, you need to go back to the simulation. Fix the simulation requires a lot of expertise. Here, with that step, you don't need expertise anymore. You can artistically redirect and change what's not good. So stop showing some slides and start making some stuff within Maya. So I made I'm an engineer, so I'm not really good 3D artist. So that's the best I can do in 3D modeling here. But let's pretend this is going to be my environment, and this is what I want to populate with a couple of characters hanging around and being autonomous. And I want this to happen really quick, right? So if you remember my workflow, first step was I want to bring my characters in and place them. So bringing the characters in, so if this is the Golem shelf here at the top of the Maya, and this is the different buttons, and I'm going to use them almost in the exact same order that they are in right now. So first, so that's the other tools to convert the characters. I'm not going to need that one. But now I want to bring my characters in. So I'm going to load one of the Golem character file I already made before. So here I'm going to use one of the presets that we're having, but as I was saying earlier, if you want to, use your own characters, no problem with that. You can just convert them yourself. So I'm going to bring one of the man character, and this is actually what is looking like. So that's a Maya character here. Pretty casual stuff. It has a skeleton. Some meshes are skinned on top of it, and it has some variation as well. The characters has a t-shirt and a sweatshirt mesh here and there. It has a short pants and long pants mesh as well, some hair, etc., etc. So I defined that as a Golem character, and now it's ready to be used. And now I can populate my scene, but maybe before populating the scene, you can see the characters. That's the size and the unit I'm going to use here. So this cube in the background, that's probably going to be an obstacles that I want my characters to be aware of, right? So I'm going to first, before doing anything related to simulation, I'm going to try computing where are the obstacles in the scene. If you've been using Unity in the past, that's something you're probably familiar with. We're going to compute something called a nav mesh, navigation mesh. And the idea is I select the geo, I open the nav mesh creator, and I'm going to specify some specific attributes. So the attributes are going to be what's the maximum step 8 I can climb. So 0.41 meters. Here, the unit I'm using is going to be meters. So it means that one grid here is 1 meter. So my character is probably 1 meter 80. So 0.41 means that 0.41 of that square grid is the maximum 8 my characters can climb on. So let's consider there was a mesh which was more than 0.41 unit 8. We'll consider this is going to be an obstacle. We can also consider what's going to be the distance between two walls in which we're able to go. What's the minimum clearance we can go under, and what's the maximum slope we can climb. As you can guess, those attributes here right now, they're set up for human-sized character. Change that. Let's say you do a creature which is really tall and you want it to be able to navigate through the environment. You just have to change those different attributes here. So when I'm happy with that, I just select my environment. I'm going to compute and save. So here I'm going to export my terrain nav mesh. So let's put it there. And that takes more or less time depending on the size of the environment. But at the end, it creates a new node, the terrain node, and in red are going to be the borders of my environment. So here we consider this is a border and my characters will not be able to go through that. And here that's going to be the limits of my environment and they will not be able to go above that plane geometry I've been doing here. Just a side note, this is for static obstacles only, right? We're going to consider that the cube here is not going to move for the whole duration of the simulation. So we can go really close to that and make sure we never collide with it. But obviously, when you got Maya objects which are animated, sometimes you may want to have dynamic obstacles. So we got another workflow for that. That's we call that external entity locator. So that's that tool here. I'm not going to cover that today, but we got plenty of tutorials which show you how you can bring movable objects and make them avoided by the other characters. Okay, now I have my environment, so I can go back into my workflow, which was placing my characters. So I'm having my man character template, and I want to place it within the simulation. So to place characters, we got that tool, which is called the population tool. It allows you to do different shapes. You can make, a box like this. You can make circles, different polygons, or you can connect that to some Maya geometry. You can use some Maya geometry as a generation zone, or you can use some selection as a generation spots. So here I'm just going to stick with the box. I'm pretty happy with the box, and let's remove maybe the grid I've been doing here. I can change the size of the box afterwards if I want to by grabbing the manipulator, which is here. And that box can be controlled in terms of how many characters I'm going to put into this. So if I select any node within Golem as attributes within Maya, fully integrated within Maya, and I can populate my zone with as many characters as I want to. I can probably change the distance as well. So when I change the distance, I end up with a kind of grid shape, which I can noise to have something more organic. And something really nice about having already the environment defined within the scene is that when I move the box, you can see that I'm never going to populate characters which are into a forbidden zone. So I always make sure that I'm not going to populate characters where I'm not allowed to. And same goes with the borders. If I get that closer to the border, you can see now the characters don't go out of it. I can change probably the orientation, noise, the orientation. And obviously here I'm using controllers, but if you want, you can paint this with textures to control the orientation, the density, or whatever you want to. So let's say I'm happy with that. I just press create. And now that I've pressed create, Golem knows that there is a simulation within your scene. So when I play the simulation, so see when I'm at frame 0, I'm back at the initial status. When I play the first frame, Golem instantiate the character. So that's really something which is really important here is that we're going to do simulation. And it means that if I want to see the result of frame 70, I need to run all the frames before until I reach frame 70. So every time I'm doing a modification, I need to go back to the first frame for the whole simulation graph to be evaluated and replay that. If you're familiar with Houdini, it's pretty similar to that or to whatever simulation package you may use. So this is my initial position of my characters. They're having some scale variation. You can see some characters are smaller, some characters are bigger. It's because when we define that entity type, that template of characters, it comes with a mean and max scale variation. You can see my characters, some have sweatshirts and short pants, some have t-shirts, some have long pants. So you got all that combination of meshes. That's also something which has been defined into the Golem character. So if I just show you quickly the Golem character, that's how a character looks like. It's made of a skeleton. So here I'm specifying, I'm having a I key chain, which stands for the leg, an I key chain, which is for the feet, one for the hand, one for the arms. It's a fully nodal. So if you got a 6-legged character, you can make your own graph here. So that's for the skeleton part. And that's for the geometry part here. So I'm specifying what are going to be my geometry variation. So I'm not going to cover that into details, but plenty of tutorials on the website in the documentation if you want to know more. And here, let's say I don't want to have those sweatshirts anymore. So I'm having a couple of characters with sweatshirts and maybe I don't want those. So here, 26% of my characters have a sweatshirt. If I don't want those anymore, just put that slider down, save that definition. And the next time I'm going to throw the sim, it updates with this. So you can see now the characters, they're all wearing the t-shirt. So what you see right now, just a quick word about that, it's not Maya geometry, it's a GPU geometry that we are drawing ourselves. So this is why I'm able to get 300 characters real time here within the viewports. So it supports everything. If you do some cloth simulation, some skinning, some blend shapes, you'll see them within the viewports. The only thing which is not supported, and you can probably tell, is shading variation here. So my characters, they're having shading variation for the skin, for the t-shirt, for the hair. But you know, on the GPU, it's pretty tough to load a lot of textures or a lot of materials and evaluate them. So what we decided to do is have better performances, but not show the shading diversity. So when you're going to render, you'll see the shading diversity, but during the simulation, you're not able to see it. Okay, so what next? Next is I want to assign some behaviors. I place my characters, now I want to assign some behaviors. So this is really where people spend most of their time, and we try to design a tool which is super intuitive to use. So this is the behavior editor. This is where you're going to design the behaviors for your characters. The way you approach that tool is that on the right side of the tool, you got the nodes outliner. So you can see all the nodes which are related to your simulation and your behaviors. So right now you got an entity type, which is your man character. Probably I should rename that. I'm gonna rename that man type. Okay, so you having your type of characters, the man type shape. And right now, no motion clip, no triggers, and just a container. We'll speak about that. And on the left part here, you're having all those icons which actually corresponds to behaviors that you can assign to your characters. So those are high-level actions that you can drag and drop onto your characters to specify what you want them to do and how you want them to do them. So I can send my characters somewhere. I can go to somewhere, avoid the characters, play some animation. I can do some ragdoll because we can do physics. If you've seen the Game of Thrones demo reel earlier, all that physics and explosions was generated with that those behaviors there. We got some specific behaviors also for animals, some characters which are not, you know, here bipeds are gonna move on the ground, but let's say you do fishes, spaceships, birds, you want to use, you know, avoid 3D avoidance and 3D navigation here. So we're having that kind of behaviors to solve this as well. And also we can solve traffic system. We have a full traffic system to with traffic lights and a lot of cars. Okay, so here you can see that workspace is empty and asking me to open a crowd entity type. So here I'm going to open the entity type, and right now it's empty. So that's what's happening during the whole duration of the simulation for those characters, for the man type characters. So right now they're not doing anything, and it's up to me to fix that. So here, let's say I want to have my characters, I want them to hang around that environment and avoid the obstacles. And I just want, you know, them to walk away and live an autonomous life during the whole duration of the simulation. So I'm going to say, you know what, I want you to go somewhere. You pick your home destination. So I'm going to bring the go-to behavior, put that into the graph. It becomes active as soon as I put it here. And it's a Maya node, so it has Maya attributes. So here I'm going to say, do you want to reach or flee a specific target? So here I want to reach. What's the target you want to reach? So here is going to be a random target within their environment. So each character will pick a random target here and reach it and go there. So that's exactly what I need. But obviously you can follow a curve, use a mesh as a target, use a particle system as a target, use a locator as a target, write your own expressions if you want with Python or Mel, and make your own specific 3D targets if you want to. Here I'm going to stick with the random target. Also, I want my characters to avoid the others. So I'm going to bring a navigation behavior, which will bring the navigation strategy. And if I put the two behaviors at the same spot, it creates for me that operator. So operator can be used to combine behaviors together. So here I'm going to combine the two behaviors to say, I want to play in parallel, both going somewhere and avoiding the character. So that's going to happen at the same time. Those two behaviors will perform at the same time. And just by doing so, if I now run the simulation, let's add more frames here. Now you have your characters So they're not animated yet because we haven't defined anything regarding animation, but you have all your characters picking a random target here and avoiding the other characters within the zone, avoiding the obstacles here at a specific speed. The speed is defined into the navigation behavior. So now I'm saying my characters go between 1 and 1.4 meters per second, but they just go there and reach their targets. And you may notice that some characters are actually fixed. That guy here, if we pay attention to him, I can click on him and I can actually see what's going on for that guy. He's not moving anymore. He's not moving anymore because the go-to behavior here is not running anymore. So that's probably because he reached his own target. So here, as soon as they reach the target, they just stop. They still are avoided by the others, but they just stop and they don't go elsewhere. So let's say I would like my characters, as soon as they reach a target, I would like them to pick another one. I never want them to stop within that environment. I just want them to walk and walk again and again and again. So here I can introduce another operator, which is the loop operator. And if I put the go-to within that loop, it means that when that behavior stops, it will restart again by picking a new random target position. And just by doing so, relaunching the simulation, now we should get characters who are hanging around. And you know what? I'm gonna make that zone even bigger. How many characters do I have here? Right now I'm having 400 characters. So let's make that zone bigger here. And I want it to be bigger onto that dimension here. And I want to have my 400 characters there. Okay. And what I'm gonna do is just replace that initial positioning. And when I replay the simulation now, they still get assigned with the same behaviors here. Okay, all good. Not so bad. Let's say here my characters, they're not animated. So the whole challenge here will be how to animate all those characters, knowing that some guys are smaller than others. They are turning, accelerating, slowing down when they reach their target, spinning up when they need to avoid characters. So how do you play a nice animation, make sure it's realistic, it's adapt to the ground properly, that you don't have feet sliding, etc., and it doesn't, you don't spend too much time with the animators making you thousands of animations. So we decided to go into a specific direction, which is called the locomotion. So here we looked at especially what do video game people do. You know, when you play a video game, you control your player, you control the character, you send him an order. So here you're saying, I want you to go into that direction at that speed. And the character plays a nice animation giving that order. So that's exactly something which is happening here. Here we are saying that if we want to avoid the other characters and if we want to reach the target we've been specified with, we need to go into a specific direction at a specific speed. And you want to play a specific animation to reach that order. So I'm going to use the locomotion behavior for that. It's a specific behavior we made for exactly that purpose. And within that locomotion behavior, I'm going to load some clips. So here, those are some clips that we made. We used the mocap system. We made those clips. We converted it as a Golem assets. But as always, if you want to bring your own characters, your own motions, feel free to do so. Just a quick word about those. So we're having 3 different walk animation. We're having a slow walk animation, a regular walk animation, a fast walk animation. We're having a stand animation, idle on spot. We're having a run animation and some turns. So we're having a turn while we walk. We turn at 45 degrees on the right side, 90 degrees, 135, 180. So I'm going to take all those motions here, and I'm going to load them all within my locomotion behavior. And you may have noticed that I just had the right side turns. So what I'm going to do is here, if I want my characters to be allowed to turn on the left, I'm going to ask Golem to also generate a mirror version of those animations. So to have both the turn right and the turn left. So I'm going to enable mirror for all the turn animations I'm having. So that's, that's 8 animation here. So there's one here, one there, one there, and one there. So before maybe explaining how does that behavior work, I'll just let you see what's going on here. So you can take a look at all the characters here, each character here, and you'll see that they're playing a different posture. They're playing a different animation here. And no sliding feet, fully adapted to the ground. Well, the ground is flat here, but if I had a bumpy ground, they will adapt properly. And all gathering to the target, avoiding the other characters. And now you're having a realistic simulation, and it took us like 15 minutes while I was speaking to, generate that kind of simulation here. So what's happening? Maybe I can unbug what's happening here. I can click on a character and see what's going on for that guy. So this is the visual feedback. I open it like previously, and that guy allows you to see which behaviors are being played onto that character. Also, when you open the behavior editor, in green are going to be the behaviors which are running for that character here. And here, that guy, this is his current postures. And when you're having a locomotion behavior, you end up with that weird display here. So let me explain. Every time I loaded a motion here into the locomotion behavior, what we do when the simulation starts is we open that motion and we extract how fast the motion goes and how much it turns. So that gives you two data, one which is an angle, are you turning on the left, on the right, or going straight, 0 degree, minus 45 degrees. And how fast do you go? 1 meters per second, 2 meters per second, 2.5 if you're running. And those two data, the angle and the speed, we put that into a 2D space. And what's happening here is every single vertex, every single triangle here is made of 3 vertices, and every vertex is a motion actually. So that vertex here at the highest peak of that diamond is the fastest animation we have. So all those motions, they're ordered by how fast they go. So this is my run fast animation. This is my walk fast animation. This is my walk normal, my walk slow, and my stand animation. So we took them and placed them onto that axis based on their speed. And on the left, this is all the turning left motion. So this is the 45 degrees, walk and turn, 90 degrees, 145, 180. And the red dot is the order we've been giving. So if we want to reach our target and at the same time we want to avoid characters, this is what we need to do. And all characters, they get assigned with a different order based on if they need to avoid someone or not. And that order, so it doesn't refresh here because I'm having zoom enabled. But if you don't have zoom enabled, you'll see that red dot moving everywhere into that graph. And at every time we're blending different frames together. So here we've been asking to go at a speed of 1.52 meters per second straight. But obviously we don't have that exact same animation. So what we do is we take the 3 closest animations. And as I was saying earlier, we got a ways to blend motions together without having sliding feet. So here we generate that new animation by blending animation, which looks similar to what we're looking for, but we blend them together to generate here a new animation. So I hope that makes sense. If not, feel free to put questions here because we're going to move forward for that. Okay, what else can we show? Here, all my characters, they are, playing the same behaviors. What if I want to have something specific happening at some point? I want my characters, maybe when they get into a zone, I want them maybe, I don't know, to explode, let's say. So let's do that. Will be fun to do some explosions. So let's try by putting, first I'm going to put a zone. So here I'm going to creating like a Maya polygon here. I don't really care how much is it attached to terrain or not. I'm going to make something like bigger. Something like this. So as soon as the characters will hit that zone, I want that guy to explode, to go up. Let's say there's a, I don't know, like something on the terrain which just make them explode. So first I'm going to bring a new behavior. I'm going to bring some physics behavior, and I'm going to put that in parallel with the rests. And that behavior just allows to turn my characters into physics. So I can turn them into dynamic, and it just means that if we do that, here, I need to enable the trigger. Let me just change the trigger. We're going to speak about the triggers a bit later. But here, there. So if I turn my characters into dynamic, they're just going to be like regular ragdolls. So you can see they're just falling on the ground. Nothing really fancy here. It's fully handled by the physics engine. It's computing all the collisions with the ground and the different shapes of the character. So this is how my character is going to be approximated with physics shape. So here, you know, they're not intelligent anymore. There's no brain into this anymore. They're just fully ragdoll. So it's not really realistic, right? It's okay when you do rigid bodies, such as maybe a car, but when you do soft bodies like human characters, you got nerves, you got brains, you got a lot of stuff which are going on to, you know, fix your positions while you're falling. So you can use that one here, or what you can do is go with full animation. But if you go with full animation, you don't have that collision with the ground. So you want to find the best word. You want to have both the physics, but also the animations, because falling and you trying to catch your balance with your arms or trying to put your arms in the back to protect yourself is something you only get from animation. So we got also something which is called Servo. So Servo means that you can have both animations and physics being played at the same time. So if I do that on my characters, they will not look really nice here. They'll still play their walking animations, but they are falling. So probably it will be better to trigger another animation here, like a falling animation here, instead of playing a run animation or a walk animation. But I don't have such animations into the package. So yeah, keep in mind that we wouldn't have to put another motions there, but you just get the idea that now they're getting controlled by the physics system. But the thing is, I want that physics behavior only to get triggered when my characters get into the zone. So rather than here, I change the default trigger. So what I want to use, so on each side of my behaviors, I can specify when does my behavior start, when does my behavior stop. And when I click on any of those, it opens, you know, a new panel here in the bottom, which tells you what's the condition for that behavior to start. So the default condition is always true, which means my characters always start, and my stopping condition is always false, so it means they never stop. So it's really up to you here to change that. And what I'm going to do here is to change that true trigger. I don't want that to start every time. I want to use a zone. So I'm going to set this as root. So now it becomes active, and that zone here can be controlled. So I'm going to put my, let's save the scene. I'm going to put my zone here, my plane, connect that to my zone. So now my plane is connected here. I'm going to say it's a 2D zone. So it means it's going to be the projection of that character within that zone. Or you can say it's a 3D zone and we're looking for a volume. You can say if the polygon is going to be deformed, if their vertices animated. And now if I play the simulation, only the characters which are within that polygon or the characters which will enter that polygon will be turned into physics. And they're falling on the ground because they haven't specified anything else regarding the force. So they're not exploding yet, but that's going to be my next step. So let's put that below. Now you get an idea of where that zone is. Oh, and by the way, let's say I don't want to have all the characters which are in the zones to fall. Maybe I can combine two triggers together. I can bring a random trigger, say I just want to have 75% of my characters, and I want to combine, I want to combine those two triggers together. I want to check if you're in the zone and if you're part of those 75% being randomly picked. And now if I rerun the sim, I should get some characters which will not care about the zone. 25% of them will not care about the zone, like that guy here, that guy there, but the others, they're just falling. And if you want to maybe to have some fading, here all the characters are falling at the same time, maybe you want to fade that to have something more organic, I can bring a fade node. So first I'm check if I'm in the zone and if I'm part of the 75%, and then I'm fading that result to have something more fuzzy. So I'm gonna fade on 25 frames. And at the beginning, just a few characters will fall. At the end, so that's my frame 1, that's my frame 25, and I can draw a curve like that. And now I'm having kind of a fade, so the characters will not fall all at the same time. They take between 1 and 25 frames to fall. And you got something more organic. Okay, great. I promise that those guys will fly, so let's make them fly. As soon as I turn them into the physics mode, now I want to apply a force to those guys. So I'm going to put a force behavior next to those. Oops, let's zoom that down. So first turn into physics, then apply a force. And the force can come, maybe it can come from a locator. So I'm going to create quickly a locator in the scene, which is here. I'm going to put that below the ground. So the force will come from below. So that will bring my characters up. And I'm going to connect that to my force behavior. So I'm going to use that as a direction and also as a magnitude locator. So I'm going to specify what's the maximum distance for that. Oops, what's the maximum distance? So it's going to show you just a influence sphere of what's going on here, and what's going to be the magnitude at the max. At the max distance is going to be. So the closest you are from the locator, what's going to be the force you're going to get applied with. So 5, and the further you are from the center, the minimum the force. And here, when you're really close to that, you can apply a bigger force here, and let's see how it goes. And now you're having your characters being, being pushed from that locator that we've been specifying. It's probably not big enough, so I'm just going to change that force. Probably put something more here, maybe 45. Okay, and we're going to kind of end the simulation part with that and switch to rendering and lighting. Okay. And yeah, remember what I was saying earlier, probably will be better to put a specific motion here. Once again, when the people did Game of Thrones, they had all those animations of characters trying to solve their balance. So this is probably the right time to trigger those. You can use the triggers, put some more animation here into the system and trigger them when you need it. Okay, so let's say I'm super happy with that simulation. My characters kind of do what I expect them to do. And I need to send that to approval. So first thing I want to do for approval is I want to bake and, I want to export the simulation result. So I'm gonna go into, I define all my behaviors now. So I'm gonna export now my simulation. So simulation export, here I'm gonna bake the simulation results. So here it's running the simulation for me in the background. And it's recording all the postures of my characters into a separate frame cache. So here you can see every frame will be a cache file, and it just stores the positions, the orientations, and the scales of all the bones for all the characters into the file format. And when it's done, so right now we are in simulation mode, so we can't change the time to see what's going on here. But when it will be done, when the simulation will be exported, we'll be able to move freely in the time and see the simulation results pretty easily. And send that to rendering or send that to lighting if you need to go through lighting first. So it's almost done. And when it's done, you can see here, we don't need that. You see that now the timeline color changed, and now I can move freely in the time, and I can change the frame and see what's going on to that frame here. And a really nice thing about not baking the geometry is that I'm still interactive here. And if I change my mind again about the sweatshirts, remember I removed the sweatshirts at the beginning. Let's say you change your mind, or the director changes mind, and you want to have more sweatshirts. You can say, okay, I want to have 33% of the people with the sweatshirt. You can just go here, change your weighting system again, and just refresh the cache. And now you're having your characters with the sweatshirts back because we haven't baked the geo. So at any time, we can change anything about the characters and see the result of that. So, okay, that's good. And now if I want to send that to rendering, as soon as I've exported my scene, I should be good. So I'm just checking before I'm sending the render that everything is proper. So this is a render checker. As soon as it tells yes for everything, it means that your scene will render fine. So let's see. Here I'm going to use Arnold, but as I said earlier, we support Redshift, RenderMan, 3D Light, and V-Ray. So I'm already having a light into that scene. Yeah, okay, all good. So I'm going to open just the render view here, make sure that I'm rendering with full resolution, which is fine, and launch the render. I could use the Arnold render view, doesn't make any difference. So what's going to happen here is every time we're having a character somewhere, we're going to place a bounding box, and the Golem plugin, when an Arnold ray will hit the bounding box, it will generate the geometry when you need it. So yeah, let's that to happen. Probably it's yeah, as I'm rendering you, it's probably gonna affect the quality of the video or the sound. But yeah, it took 20 seconds to render those 400 simulation with the default settings of Arnold. As I was saying earlier, you can see we've got shading variation here. Some characters wear a green t-shirt, black t-shirts, blue, different colors there based on the shading assignment and the shading diversity that I've been specifying onto that character. Okay, so here we made simulation export, we did rendering, which is good. What about layout here? I spoke about that layout stuff. What is it exactly? So let me maybe hide some stuff here first and clean the scene a bit. So here what you have into the scene is the result of the simulation, right? But let's say the director comes and say, you know what? I just want to have more characters here in the foreground. And that guy here is really close to the camera. I would like him to wear something different. And probably I want his head to turn to look at to that guy here and remove those guys. I don't like them at all. Or, you know, that kind of modifications. And with whatever the other system that you pick, you'll have to, you know, go back into the simulation, change your behaviors, rerun the sim. Takes a long time, takes a lot of expertise to know the behaviors and know how to change that. So you don't want to go through that. You really want to be able to grab your characters and do whatever you want to. So yeah, you want to remove those characters, go F9 within Maya, which is component mode viewport, select those guys and maybe move them. Like, okay, I don't like them here. Let's put them here, for example, there. And well, I want them to face the camera rather than looking into the side. And you know what? They're maybe too close to each other. So I would like to scale the positions between those guys. So I'm gonna go into the scale mode here. I'm gonna change the axis to word axis, and I'm gonna scale those guys. And what I'm scaling here is gonna be the distance between those guys. And what I've been doing so far, and that's really, really important here, I've been applying some layers on top of my cache. So all those operations I've just did, they're recorded into the layout tool. So this is the layout step. This is Golem Layout, which comes as a sub package of Golem. When you buy Golem, you get the layout, but you can also buy the layout separately. And what I've been doing here is I was selecting those characters. So here you can see now I changed my current activation of the graph. I applied a translate operation, which moved my character slightly. So here I moved my character by 7 units, minus 7 units on the x-axis. I also rotated those characters and I expanded the difference between those characters. And let's say here you don't want, let's say here you want to add more characters to that graph here. Let's say those guys here, you want to apply the same transformation. You can just select those, bring a new selector node, which gets populated with the same, with the right IDs of your selections. And you can just connect that to your graph. And now those guys get assigned with the exact same transformations. And if I remove, let's say the expand, now they're not expanded anymore. They're just rotated. And if you want the expand to be back, you can just replug that expand stuff. And something which is really important is that this here, it's non-destructive. It's like you're in Photoshop, you're having your source image, which was the simulation, and you're just applying the layers on top. So you're not changing, touching the cache, you're having your cache, and on top of it, you're applying deformations. So it means that you can have one cache made by one simulation artist and give that to multiple Maya artists. The same cache, you can give that to multiple Maya artists who are just taking that cache as a source, but just changing the characters' positions and orientations until until you have something proper. So that's the really nice part about this non-destructive workflow. So what else do we have? I can bring maybe another selector here, there. And within that selector, I'm going to say, you know what, I want to select everybody. So here I'm using the star keyword, and the star keyword selects all the characters. And I want to duplicate everybody. So now I'm having twice more characters into the simulation. And just to make sure that I'm having twice more characters, I can just bring that patch here and move that elsewhere. And I duplicated the full simulation here and put it there. And as they're exactly the same, I can probably time offset them slightly. So So I'm gonna just provide a slight frame offset so they don't have the exact same posture. I'm gonna shift them by 10 frames in the future. So those guys are playing 10 frames in the future than the others. Okay, I was referring to changing maybe the meshes of some of the characters. So let me pick one guy here. Let's say that guy there. Okay. So that guy here, really close from the camera, maybe you want him to do something else. So I'm gonna bring a new selector. And as soon as I'm having my selection made, my selector node is populated with the right stuff. I'm gonna bring add remove mesh assets. And onto that guy, I want to add the sweatshirt. Now the characters has the sweatshirt as well than the t-shirt. And what I want to remove, I want to remove the t-shirt. And that guy here doesn't have the t-shirt anymore. And I really like that modification and I want it to be applied to another character. Let's bring another selector, connect that here. And now that guy wears the sweatshirt as well. So you can copy paste your modifications and apply them onto other characters. Okay, and what if I need to reanimate that character here? So with the with the casual with the casual crowd software workflow, anytime you need to reanimate some characters, you need to export that guy as an FBX, and you can just give that to your animators and remove that character from the crowd, and it's not good anymore, and it's a really cumbersome process. Within Golem, we decided to put a layer for that. So we're having a rig node. So I'm gonna grab that rig node here, create the rig here for the character. And now you end up with a full iKey rig onto your character that you can give to an animator. It's fully compatible with Maya keyframe systems. And it's a full, 6 dimension, 6 degree of freedom iKey here. So I can change the orientation of everything I want to here. Change my iKey, and you can use Maya full features to reanimate that characters and all those, all those deformations that get stored here. So if you don't want to have that anymore, you can just remove that and you can see the characters go back to his positions, or you can reapply that and now you applying that deformation. So you can put keyframes here, you can do whatever you want to and save that as just a layer that you apply on top of your cache. So I'm gonna save that as my layer. And once again, you want to apply the same deformations onto maybe that guy here. I'm going to go F9, select that guy here, bring a new selector. Oops, it's starting to get messy. I should have grouped this. And apply that deformations. And what's happening? Oh, I should get, not sure why. Oh, sorry, the selector was empty. So set. Yeah, and now that guy gets applied with the same keyframe system that you've been specifying onto the other character. And obviously we got, some kill nodes. So let's say I want to, let's go back here. Let's say I want to kill those guys there. I can select them, bring a kill node. Oops, and sorry, I need to bring my selector first. Select my characters here. Oops, there. Set. Okay, and no, set. Oh, sorry, my selection went off. Okay, so select my characters, kill them, not existing anymore within the simulation. And if I save this and just re-render that with Arnold, now all those modifications I've been doing, they're gonna be applied within Arnold as well. Okay, so I'll just let Arnold process this. And I'm not going to move the mouse or not speak anymore because the computer is taking full power here. And when it's done, so yeah, twice more characters here, but still rendered in a super efficient way because all those characters get duplicated. All the deformation you've been applying, all the mesh modification you've been applying, all repercuted onto your characters. Okay, so that was the layout part, plenty of nodes to play with and really taking advantage of interactivity here. Now you can have your artistic art director next to you or the director next to you, and you can control like in real time what's going on into the scene. You want to remove some characters, you want to change the trajectory of the characters, you want to change a blend shape value, a shading value, whatever. You just change it with the director next to you so you don't have to take hours of days to iterate on the shot anymore. You can just use layout operations here. Okay, happy with that. So let's say I'm really like that simulation. Oh, and sorry, last thing I would like to show you, which is super important. Here, it's convenient because everybody is on the flat ground, right? But what if the terrain changed? What if here, my flat ground is not flat anymore? So I'm gonna duplicate that polygon here, and I'm quickly gonna sculpt this. Okay, let's sculpt this, and now it's bumpy, it's not flat anymore. But the characters, they've been computed, so simulation is not happening anymore, right? So my characters, they just know that this is a flat ground. They don't know about the new environment. So what's going to happen here if the ground has changed? Obviously, sure, one step is you can go back into simulation, previously into simulation, but you lose all that flexibility. So what we allow you to do is to take that new geo there, that new terrain, and say to Golem, this is the new terrain, even if the footprints and the I key and everything has been computed. So I'm going to take, here I'm just having one mesh, but if you're having multiple mesh, it doesn't make any difference. And I'm going to save this as the destination terrain. And as soon as I save that, you'll see that the characters now get adapted to that new terrain. So nothing fancy, because we knew the previous 8 of the characters, and now we know the new 8 of the terrain, and we just apply a snap. So if we pay attention to footprints, they're not really adapted to the normal of the ground. But the thing is, with that layout tool, we've been adding some new layers, and one which is especially made, so here I'm selecting everybody, and we're having a ground adaptation layer, which is fully made to do full I key ground adaptation. So pay attention to the characters which are within the slope here. When I'm going to change the snap A to with I key, you can see the characters, their orientation changed slightly, and their legs, their knees, the orientation of their feet changed slightly also to adapt to the ground. So even if everything has been computed on on the flat terrain, you can still readapt on a full, complete new terrain there. Okay, and I'm just having 5 minutes to end up here, so I'm going to save that scene, and we've been doing some work within Unreal here. So I'm going to show you how you can bring something within Unreal. So I'm going to save that scene that I really like as a preset within the Golem library. So we got that library where we can put plenty of different presets and use that for later. And what I'm going to do is within Unreal, I'm going to create a Golem cache node. So that's a plugin for Unreal. Here, I'm going to put that at the origin of the scene. I'm going to specify that the library file I want to use is my Unreal library here. That the index of the cache I want to use is the one. I still have the terrain. And here I loaded my character. So that's the same character that I'm having within Maya that I loaded within Unreal. And if I just connect that guy here to there, the Unreal plugin will recreate all the characters for you. And here you go, with the same terrain adaptation that the one you've been defining, with the same layout modification than the one you've been defining. And if you play here, I would love to compile the lights and everything to get proper timing and deformations, but now you can replay that within Unreal and see the exact same simulation happening in Unreal and render that within Unreal. You can use the sequencer as well and other casual tool to make your own cinematics. And I guess we're kind of good with that. So let me stop this. And I try to grab maybe some questions from the chat box. So now it's a good time to ask questions if you have any. Let me try to catch up with the start of the conversation. So it's going to take me just a couple of minutes here.
So Nicolas, I've been noting down the questions.
Oh, that's excellent.
Spare you that trouble.
It really makes my work easier. Here, go ahead.
Yeah. So the first question we have is from Hitain. So his question is it compatible with Houdini? So I think there are another 2 questions.
Oh, yeah, sure. So here I decided, as I was kind of limited in time, I kind of decided to only show Unreal. But we do have also an Unreal integration, which is really similar to what you see within, we're having a Houdini integration, which is similar to what we're having within Unreal. So if you go on houdini.golem.com, you'll get a full documentation about how you can grab and get your crowd within Unreal. And multiple ways of doing that. So we got a home plugin, but also we're taking advantage of USD. So it's Disney Pixar new tech to be able to bring simulations in and out of different DCCs. So we're using USD as well, so you can export your crowd as a USD file, super light file, and Houdini, especially Houdini 18 with the new Solaris platform, can bring that USD on, and you can see your full geometry, override what you want. And just to finish with that, the people at Rodeo FX, so it's VFX studio from Montreal, worked on Game of Thrones, for example. They made us a tutorial about how they used Golem within within Houdini right now. So if you check for Rodeo FX Houdini Golem, you figure that video. It's a 1-hour tutorial about how you can bring your crowd and make amazing effects with Houdini on Golem crowd characters.
The next question is, can we do more modification in the attire of the crowd, like some people wearing a blazer or a casual wear?
Sorry, what kind of modifications?
To change the attire, to change the dress of the crowd, of some people in the crowd.
Yeah, sure. So here I showed that you can replace assets with what you had before, but you can edit as the geometry is not baked, is never baked. You can edit whatever you want, which is related to geometry. So you can add more meshes and you just have to skin them and they just become available, or you can add more shaders, more shading assignments, override everything you want to. So either by using the Golem Character file tool, so that tool I showed you, which is able to change all the meshes and all the repetition here. But you can also change the shading and so
on. What is the RAM and GPU requirement for this type of simulation?
So here I'm having a GTX 1060. I'm running on a laptop. But the thing is, we are not really taking advantage. Well, within Unreal, we are taking advantage of GPU. But when we are within Maya, the simulation all happen on CPU. So the most thread you have. So here I'm having a i7. It's a 2 years old laptop, a Dell one. So it's pretty okay, right? But all the simulation runs on CPU. The display runs on GPU, and within Unreal, it's the same. Cache replay runs on CPU, and everything else runs on GPU. So here, GTX 1060.
Any options to change the facial expressions on the crowd?
Oh, that's a good one. Yeah, totally. Here, my character are really low definition here. They're low definitions because we expect to put, it's a stadium character. So we expect to put 80,000, 100,000 of those into a stadium. So they're really light in terms of geo, in terms of skinning, in terms of bone. They're like 32 bones or something. We remove the bones from the fingers and the feet. We just have one for the wrist and for the thumb, and that's it. But obviously we do support blend shapes. So you can make, we support bone for facials. So one casual rig that you can do is probably one for the jaw, one bone for the jaw that you can control with just orientations, and put blend shapes maybe for the blinks, for the facial stuff, and all of that. It's fully integrated. The blend shapes would be like any bone. They're just animation channel. So we just record that along with the animations. We blend that as well. You can also use procedural animations to do some automatic blinking when you need it. Connect that to whatever you want to with the expressions if you want. So yeah, it's fully controllable. So I should have probably tell that, but you can grab the software for free on our website. If you go on download.golem.com. Sorry, download.golem.com. You can grab the software for free. Comes with a learning license, which is time unlimited, so you can use it as long as you want to. Only makes watermarks when you render, but you can learn the software. You can use the assets, and as part of the assets that we provide, there's a cartoon characters which has blend shapes and facial deformation. So you can play with that character and play with the facial expressions if you want to see how that works.
Cool. The next question is, can we auto-hide the characters who go beyond the operational plane, like bounding box, to avoid calculation?
Yeah, sure. We got multiple ways of doing that. If you want to maybe remove characters from the simulation, because simulation costs a bit, because every single character bone needs to be computed. So if you don't want to compute a character anymore, we're having one behavior, which is the kill behavior. You can see it's that guy here. It's the character with the eraser icon on it. And you can trigger this whenever the characters are within the zone or not within the zone. You can invert the trigger. You can kill some characters, so they will not be computed anymore. And we also have the opposite, so you can emit character. You can create characters. Let's say you turn the camera and you want some characters to pop at some specific timing. You can use the emit behavior to emit some characters here, or kill the behavior, which is the opposite here. So that's one way of doing it. Let's say you did your sim, but afterwards you want to eliminate some of the characters. You can also use the layout tool to do that. Or we also have automatic frustum culling. So you can take the camera positions and the frustum positions and some margin, and everything which is not within that margin will be removed. Maybe I can quickly show that into here. If I go into the crowd manager here, into the advanced attributes, I believe. So it's something I haven't used for a while. So I'm going to say the camera I want to use frustum culling here is going to be the first camera, and I want to enable that. So obviously here we will not see any difference, but if I probably create a new camera, Golem Materials, and create a camera and switch to that new camera, I probably will see that my characters are not being drawn anymore. So you can see here in the borders of my camera frustum, it's not displayed anymore. If I move my persp camera, which is, I don't know, it's okay, it's there. Can I move it? Yeah. If I get closer, you see that all the characters which are outside of the frustum, they're not being drawn anymore and they're not being rendered anymore. So that's also a good way to make sure that you always render what you get, what you see.
Okay, so the next question is, can we add a girl to the red t-shirt character only?
Can we, so go again, can we?
Can we add a girl, like you change the character of only the crowd which is wearing red t-shirt?
Okay.
Maybe a red t-shirt is a parameter for changing the model.
From selection, yeah, I get that. So that's something where it's not available yet, but it's on my list for a while. So actually the selector, I haven't really played with a lot of options here, but we got one which is star, but you can also select characters which are only of a certain type, characters which are only using some certain character files. But right now there's no way to filter based on assets. It's on my list, and I'm quite sure we're gonna add this soon. So we got a new version every 3 weeks, so we do a new release every 3 weeks. So stay tuned, check the release notes because it's in the list. That's something we want to do, but I haven't had the time to do so yet.
Perfect. The next question is possible to customize looks of the character as needed or as per project?
Yeah, totally. I haven't really spoke about the way you create your characters, but that's something which is part of the characters data that you do. So when you create characters, so here I'm using really like a global character, but let's open it. And when you define the look here, you got that panel here on the left, and that panel can be used to make a per shot repartition. So you can make a master character with all the assets you need, with all the variations. So here I'm having a variation for the undercoat, which is either the t-shirt or the sweatshirt. I'm having a variation for the pants, short pants, long pants. So you just create the variations, and let's say you do a new shot, like shot 2 of sequence 1. You can create a character type just for that, and you can customize the assets repartition, especially for that shot. And when you're within Golem, so I'm going to say this here, and when you're within Golem, you're going to say, you know what, the type I want to use here is going to be shot 2 sequence 1, and this is what I'm going to assign to my characters. So you can do some shading assignment, some characters, some mesh assignment, name that the way you need, and save your character and assign that per shot. And you can also do that. Let's say you want to do that afterwards with layout. We're having a node which is dedicated, I guess is that one here. We're having a node which is called set rendering type. And as soon as you do that here, oops, you can also here override the type that you want to use onto your characters there. So you always, you can like override per shot, even once the simulation has been exported.
The next question is, after cache, if we move the characters or duplicate them, will they still intersect with each other?
Yeah, they will.
They
Yeah,
will.
sure, they will. That's the counterpart, right? No more AI. When you're in layout, no more AI. So it means that you are driving yourself the positions, and it can result in collisions. And that's the, I was gonna say funny. Well, it's not funny. You can just grab your characters, move it away, or you can take the trajectory and change the trajectory to avoid that collision. But the thing is, what we see more and more, we've been seeing that a lot of in animation studio, they really want to have artistic control of what's going on. So if there are some collisions, they just remove the collisions manually. But even in VFX, we can see people who are using more and more the layout. And if you pay attention to some of the recent movie, I'm not going to tell movie names, but if you pay attention, there are collisions. There are collisions. Here and there, a couple of collisions for just maybe 2 or 3 frames. There are some collisions between characters, but as soon as the shot's been validated and, you know, with the actions, you don't take care, well, you don't take too much attention to that, and it's not ruining the quality and the realism of the shot, no problem. That's the stuff, because you had artistic control, so you set everything the way you want to. There are some collisions, sometimes they're in the background, they're motion blurred, but yeah, there are collisions all the time when you do layout. That can happen, and you just have to check if within the camera value, if something's going properly. This having been said, if you don't want those collisions to happen and maybe you want to remove characters, we also have a way to select characters in collisions, and you can just apply a kill node on that and they will just disappear from the layout.
The next one is it possible to modify character after import in Unreal?
Yeah, so yeah, true. I haven't really showed that, mostly because I just reinstalled Unreal, so I'm using 425 here. But that layout tool I just showed you, it's supposed to be available as well within Unreal, so you can do the exact same modification than the one I've been doing, but within Unreal as well. If you, as a proof, if you go into a window here, the Golem menu, you got the Golem Layout editor. But the thing is, within Unreal, I need to install a Python package because that layout tool is relying on Python. We show the process on the website. It's just one command line to do. But I just figured, like right before starting the demo, that I haven't installed that. So if I open the library, nothing is happening. And if I take a look to the output editor, I'm not even sure where this is. It will show me that that package is not installed, so the tool can't open. But yeah, you can change the assets if you want, change the shaders, same stuff than within Maya, but within Unreal as well, and within Houdini as well. The same plugin goes within Houdini, within Katana, and within Unreal with that layout tool on top of that.
Cool. The next is, if we need a fire or a liquid sim attached with the crowd, how is that handled?
If we need a sim of what? Of fluid?
Yeah, of fluid dynamics, yeah.
So that's kind of a tricky one. If it's if it's like a one-way integration with the crowd, so okay, there's actually 2 ways of solving that. Let's say you have your crowd, it's already done, and you want the fluid to interact with the crowd. So just one way. Here, the fluids will just, as soon as they hit a character, just the fluid will interact with the crowd, but the crowd will not do anything related to the fluid. That's something which can be done super easily. You take the Houdini plugin or the USD integration, or within Maya, you just bring your characters as a geo or as a geo proxies, which is a lightest version of the geo, and you can make your simulation and you have your fluid reacting to that. One really casual ways, if you need to generate the dust, when the characters walk in the sand, you need to generate the dust, which is generated by the footprints. You just bring your characters within Houdini with the Houdini plugin or with USD, and you generate the dust. Else, then you got the second interaction, which is you having your fluid simulation, which has been made already, and you want your characters to react to that. you can just bring that as an Alembic particle cache within Maya, and you can react to this. So we are taking into account particle fields. So if you want to, your characters to move with that fluid, that's something which can be triggered. You can control the force behavior, the one I've been using before to push my characters up. You can use your wave or your fluid simulation as a source, and we're gonna fetch the different magnitude, the different forces, apply that to the different rigid bodies. If you want the two-side integration, it's pretty tricky because within Maya, there's no fluid system that we can interact with. And within Houdini, the simulation is not happening. But stay tuned in the next release, especially after summer. We'll have something to have dynamic simulations both ways. But right now it's one way.
Cool. So what is the scope of AI in Golem in future?
What is, sorry?
What is the scope of artificial intelligence in Golem?
Okay. What we can tell is AI, in what I've been showing is, so AI can, it's a wide word to say a lot of things. So I'm going to say it's, AI is just a resemblance of intelligence. So what is resemblance of intelligence? I would say the navigation and the go-to is probably a good way of AI. It's not deep learning as people will say AI is, where we're not using deep learning yet, but we're looking into that. And probably that's going to be one of the next announcements we'll do after summer as well. But if we just speak about AI, the navigation behaviors that we have, the stuff which is able to feel the other characters, get the appropriate speed, slow down, speed up, turn, and avoid. That's totally AI here. This is what we call human AI or human behaviors simulations. And we got also AI, I would say, for the animation, the way the characters adapt, play the right animation at the right time. That can also be called AI, but not deep learning or machine learning as probably you would expect.
Yeah.
The thing is, with machine learning and deep learning, you lack control. And from our experience, especially when you do VFX or animation, you want to have control on what's happening. You're not always looking for realism. You're looking for Hollywood or Bollywood realism. Your own cinematic realism. So we provide some tools which allows you to quickly deal with stuff, but afterwards we mostly provide tools on top of that to provide artistic control on top of the simulation.
The next one is, can we switch group of crowd geometries with hero characters?
Yeah, totally. So I was referring to that layout stuff earlier because most of the time you want to have hero characters reanimate that, but sometimes you want to do character effects. By the way, I haven't had the time to do so, but we do support hair system, clothes simulation. So if you had characters which are highly defined, we can do clothes and we can do hair on your characters to get hero kind of characters here. But let's say you want to bring some characters and promote them as hero. You can just select a bunch of characters here. You can go into the simulation baker, say that you want to take those characters there, and you can export them as USD, FBX, Alembic, really up to you here, and it's going to bake them as a geometry file format there. So it's mostly if you have no other choice, because we would always advise to stay as long as you can into the crowd workflow, because the caches are really light, it's non-destructive, you don't have some pipeline to do around it to extract some of the characters. You can still stay within the crowd pipeline, but if you don't have any choice, that's one way of doing it.
The next one is it stable to use it with multiple referencing in the production pipeline?
Yeah, sure. Oh, please do. I've done a lot of efforts, especially in the Golem 7 version, to deal with references. So with rendering, lighting, all those stuff, no problem. With simulations, you just have to use the Golem menu and to create a reference. So what you can do, and we've been testing this in multiple pipelines, you can do your entity types in one file, your behaviors in one file, your motion clips in one file, reference everything into everything. You just have to use the create reference or the update reference menu options. We also have some commands if you want to pipeline this into the studio. The reason for that is because we are doing some specific connections. When we create a node, we connect it to some specific things within Maya. like the time node, like the Golem manager node, like the nucleus, sometimes when we do some interaction with physics. And if you want your simulation to still work as it was working before, we need those connections to be updated. So you just have to use those menus here, but it comes with an API if you want to pipeline that.
Sorry, I muted myself by mistake. The next one is this plugin compatible with other plugins like FumeFX?
Not directly, you will have to,
Okay.
yeah, because they don't provide
A
API.
similar thing
So
like
yeah,
having compatible with
it's like the fluid.
fluids.
So you'll have to go probably through Alembic is the right interchange file format here, but not directly.
Like Golem for Maya, is there Golem for Houdini is available or planning to develop in future? I think it's available, right?
It's available right now for simulation replay. So everything which is post simulation, but stay tuned to announcements.
Okay, cool. Is it based on .ass Arnold's file format system?
Oh, we could. We're not really taking advantage of it. ASS is the internal file format for the Arnold rendering engine. If you were about to generate a ASS file for that, that would generate a really huge one, like gigabyte of data, even if it's compressed. So we have an Arnold plugin, which is creating the geometry and writing the ASS at render time. So you never have to have those huge files that you can't really handle. We just generate that on the fly in the memory. But if you want, you can still do it. I mean, if you're going to export all and you go into ASS export, you can ask to expand the procedural. So it means that what we're writing into the Arnold engine, rather than giving that directly to the Arnold engine, we're putting that into a file. So you can bake as a geometry if you want it. But we really usually don't advise to do that because you're doing crowds here, and I'm having thousands of characters there, and that's going to be really huge because we're writing everything, the vertices, the normals, the UVs, the shaders. So really heavy.
The next question is, as we cache 400 characters, duplicate them and move them around, will this new set intersect with the original set? If yes, is there a way to fix it?
They can. That's what I was kind of saying earlier. If it's cached, no more AI, so no more avoidance. So they may intersect. The way to fix that is you can filter characters by collisions and just to kill. So within the selector, I don't remember the keyword exactly, but you can bring a new selector, write the expression, which is kind of collisions at frame whatever, and apply a kill node on it, and that would just kill the collisions. But as what we can see from the industry, the feedback on that is when the collision can be noticed on camera, people just change the trajectories or move the characters, add an extra deformation layer, or they just leave it. If we can't see it from the camera, maybe it's in the distance, they just leave it with the collisions because who cares?
The next one is, if you have a specific design character models, can we use that for crowd?
Oh yes, please, please do. I mean, what I was showing here, and I really want to make a point with that, is here I'm using template characters that we provide. But I mean, if you take a look, I'm probably gonna run the reel in the meantime. If you look at take a look at the reel, we got the people from Digic in Hungary, or the people from Blur. They're doing all those cinematics for League of Legends, and obviously that's their own characters that they've been doing themselves because you want to use your own characters at some point. And I haven't really spoke about that process, but you just have to convert those characters into the Golem file format. It's just a matter of creating, the skeleton, specifying how does the skeleton looks like for Golem. So you're having a Maya skeleton here. Maybe I can quickly go through that process and show that afterwards. Let's say I want to use that character here, which is below the ground. Let's say I want to create a Golem character out of it. It's just a matter of selecting the skeleton first. And I'm going to create a new, let's start fresh. We got tutorials which cover this completely, but here I select the skeleton here first, load the selected skeleton, specify what's the up axis, front axis. If you're using biped or quadruped characters, you just do the auto compute skeleton mapping, and now you're done. It computes automatically for you all the key chains, everything, and that's the skeleton part. If you got blend shapes, this is where you specify your blend shapes. And for the geometry part, you just import your Maya nodes and just specify where are going to be the variations, and you're good. This is how you do your own character. And this is a Maya character with an advanced skeleton rig, but we don't really care about the system. And all those crazy, all those crazy examples of creatures like that one here is not something that we provide, right? It's something that the customers, so here it's Digic work, they provide their own characters with their own system, with their own blend shapes. Do zombie from Game of Thrones, they're provided by the customers as well. They do that themselves. They convert their own motions, their own characters. Yeah, those cartoon characters with facial expressions. Yeah, that's provided by the studio. So yeah, please use. You can use the assets we provide. We give them for free with the software. When you download the software, you can use them for free. But if you're having your own characters, yes, please do convert them. It's always funny to see, people making new characters within Golem. Yeah, that's a good example here. It's bees, full biosystem here, navigating on the face, avoiding on the face, and flying around. So yeah, complete custom examples.
Cool. The next one is, which version of Maya is Golem compatible with?
Oh, we do support from Golem, I would say 17, but let me check. So one good practice is to grab the release notes. Let me see if I can grab them here, put them here. Okay, so that's the release notes of Golem, and at every version, at the end, we specify which version of the rendering engine we do support, which version of Katana, Unreal, Houdini we do support. So Maya is going to be from 17 to 20. What was Golem? Yeah, Maya. So yeah, 17 to 20, and you can see we also support Max, same way than we do with Unreal, Houdini 17 and 18, and different versions of rendering engine. So this is the one we do support.
There's also a question whether you support Blender.
We don't. We don't, mostly for we've been taking a look, but the license Blender is having is kind of problematic for us. We're a small company, and we haven't found a way yet to be able to integrate something into Blender without being contaminated by the licensing scheme that they're having. They're having something which is really really free and open source, but also contaminates the code source, the source code. So it means that we will not be able to sell anything if we integrate within Blender. We can't sell. So it's kind of a problem for us because we're a small company. Yeah, I haven't found a way yet, but maybe that come later if something comes in.
The next one is it possible to add custom scripts? And I think that's the last. After that, is it languages Python? Does it support Python?
So custom scripts for sure. In plenty of ways. I can't really details everything, but we got an API almost around everything. If you want to, let's say you don't want to open Maya and create a simulation from scratch, convert your characters and make caches, and without opening Maya, that's something you can do with Python easily. Python, or you can even write some C++ code. We got C++ API and Python API similars. And you can do everything. You can create your characters. You can create, all the simulation nodes, everything with just scripts, and launch your simulation export and throw some rendering without having to open that. We got plenty of studios who have been using Golem for years. We got all those tools to convert characters automatically, motions. So when you go into the documentation, we got something called the technical documentation, and we got the dev kit here, so both the C++ and the Python dev kit, and some Python commands everywhere, which tells you how you can make your sim, make your characters, and so on.
Now, I think this is the last question of the day.
Great.
What should I do if I want to have just direct few characters move through obstacles manually? Means he wants the characters to move through the obstacles, and how do you control few particular character to direct towards a particular object,
True. So that's something you can do with the go-to target. The go-to behavior, you can just use that on a separate set of characters. You can select a bunch of characters and say, I want to assign a trigger to those guys, and this is going to be their target. Or that's something you can do with layout. You can select a bunch of characters and move their trajectory in layout if you want to. If you want to move through an obstacles, you can specify, you can have multiple terrains in your scene. Here, I've been playing with only one terrain. I'm just having one terrain here, which is shared by all the entities. But if I wanted, I could have made multiple terrains and assigned those terrains to different characters. I would say, those guys here, they don't care about the obstacles. So they go through the boxes, and this is their obstacles in their environment. And those guys there, they do care about it, and they're going to generate a different simulations. So that's one way of doing that. You can do that with the behaviors, with the settings, making a different crowd to do that.
Cool.
Yeah,
So do you support car traffic?
We do. Let me, maybe we'll end up with that.
Yeah.
It's parts. So if you download the software and install the character pack, which comes with it, it's going to be here within N. We actually ship within the package some scenes which are showing you how you can do traffic, and it comes with a car character. So it's called city traffic scene. And you'll see that the settings is really easy here. I made some curves. So I made some NURBS curve here. Every time I had a road, I made a curve of it. And you can select those curves and create a city traffic environment. So Golem will make all those lines for you automatically. And you can control all those curves separately if you want to. So let's say that section here of the road, you can go into the extra attributes and say, you know what, I want to have 3 forward lanes and 2 backward lanes, and what's the difference? So on every curve, you can specify what's the speed limit, how many lanes you're having, what's the distance between those lanes, and so on. And when you're having intersections between 2 curves or more, let's say here, you can say this is going to be either a traffic light or, oh, damn, you know what? Okay, I figured this would happen. Thank you, Maya. Let me reopen that scene quickly. So you can have a full traffic light system where you can keyframe the light colors, or you can let Golem decide the colors for you automatically. And you just have to launch the simulation afterwards by setting 2 different behaviors. Okay, let's go back with that. Let's reopen that scene. Let's open with Arnold. Okay, and hopefully that time that will be better when I select my zone. Okay, so that's my traffic light system. You can specify what's the size of it, if you want to have automatic system or a manual system. Here I populated the characters on the road. We got a way to populate on the road, and the behaviors, we are having a go-to behavior to send the character somewhere. Here is going to be random, but following the traffic system. And we also have where you specify what's the speed of the characters. Do you tend to drive on the left or on the right? Because we know some weird countries drive on the left side. We do drive on the right side, but we know that there are some which do differently. And you just throw the sim, and here you go. So you're having your full traffic light system here. You can see this, the light is red here. And now it turned red there. And that one will turn green. And now the characters go through it. And you're having a full traffic system being autonomous. You can do some buses if you want to, which stop at some specific locations. You can interact with pedestrians. So the car know about the pedestrians know about the car. You can react to that with physics, collision avoidance, and plenty of different things. It's also covered. We got a full tutorial about physics and cars and traffics. If you check on the website, you can get started with that pretty easily.
Perfect. And I think with that, we come to the end of the session.
Great.
Thanks a lot, Nicolas. I think we extended it by 30 minutes. That's
no problem.
Really good. And thanks a lot, everyone, for joining us here today. Be safe. Take care wherever you guys are. Stay safe. And see you around for the next one.
Yeah, see you around.
Again, we'll be sharing the recording of the webinar to all the emails that I've registered and the emails that I have.
Excellent.
Bye, everyone. Good night. Take care. Nicolas, you have a great evening ahead.
Yeah, you guys too.
Yep.
Thanks a lot for joining us. That was really a blast, and I was really excited to do that. So hopefully you guys take care, learn some stuff, and play with crowds. And if you do anything, send us an email with the result. We're always really curious about what people are able to do. So you can grab the software for free, and it just have watermarks in the rendering. So go ahead, help yourself, and stay safe.
Perfect. Thank you. Over and out, everyone. Have a
See
good
ya.
night. Bye. See ya.